name is Jordan Lemley, and I am the product manager for PDM products here at Hawkridge Systems. And today what we're going to be talking about is the data management dilemma. Is good enough good enough? So the idea behind this presentation is to give you a quick glimpse into some of the hidden costs of not using a PDM system to control your data, as well as kind of figure out where some of the time wasters are for your company and how you can eliminate those with PDM. So trying to understand, even though you've got your day-to-day operations working smoothly, what is the hidden cost for that? So I like to think of this good enough scenario as kind of a leaky pipe. There's the product generation and product life cycle that you go through a design iteration, you send that off to manufacturing or purchasing. There's communication between departments, and during that design process and during that communication process, there's a lot of overhead that can prove costly in the profitability for that product itself. So one of those areas is duplicated data. You've got data strewn across many different locations, shared network drives, people's desktop computers. You've got data that you don't know if it's the latest version or not, and trying to cipher through all of that. That has added cost. It takes time, it takes effort, it takes engineering costs, it takes it takes time. So there's also the added aspect of manual data entry. I don't know if you've ever had to create a BOM from scratch, or if you're uploading your bills of materials into an ERP database or a PLM system. Sometimes those are really manual entries, and it takes more than a significant chunk of time depending on the system that you have in place and what information needs to go into it. And so there's some manual data entry that could be automated. There's also cost with wrong revisions. Either manufacturing getting the wrong copy of a file and cutting the wrong hole or the wrong dimension or the wrong tolerance, and either scrap parts or wasted material that gets used in creating that part, or the wrong part gets shipped to a customer. That whole process of communication and those hidden costs are another way that profitability gets lost in that design and release cycle. Another aspect is searching, just your general everyday searching. If you're using a Windows folder structure, you might have some folders that are controlling your documents, but maybe you've got, once again, the duplicate data and you don't know where to search, which version is the latest one. That searching process can take time away from engineering, away from designing, away from manufacturing. And then inefficient communication. If you've ever had somebody ask you, hey, where are we at with this project? Where are we at with this design? If you've had customers asking for files, if you've had another department that needs to have files uploaded via FTP or sent via email. Some of those communications, those requests for information, that requires you to type up an email, attach a file, and that doesn't seem like that much, but how many times a day are you doing that, and how many engineers are doing that, and how often is that happening? So thinking through some of these leaky pipe scenarios where there's some profitability that's being leaked out, and the end result is less profitability for that product and less profitability for the company. So that's the basic idea of what we're going to be going through, is talking about some of these scenarios, what the hidden costs are, and so without further ado, we'll talk about the different aspects of the data management process. So we've got duplicated data. What's that all about? Manual data entry, what hidden costs are there? What happens when you have the wrong revision? What implications are there for running searches inside the vault that it's disorganized, it's unmanageable, the files are, it takes a long time to get to. Communication. Are there ways to be more efficient in the way that your customers, suppliers, internal engineering is communicating with each other? So let's take a look at duplicated data first. So duplicated data can happen when you've got shared network drives and you've stored your engineering data on the shared network drive, and sometimes it can be hard to identify the correct revision. You might have updated the revision, but maybe another engineer went in and made a change to the file, updated a revision. They forgot to rename it, or they overwrote the previous revision. There's added cost implications for that. You might have to repair broken references because somebody copied the file, the assembly and all of its components, they copied it to their desktop, but they forgot to pack and go when they put it back to the shared network drive, or they just copied it and you go in to open up the assembly and it's still pointing to that user's desktop, and so you have to go remap the references, and that takes time to go remap those references. And how often is that happening when you're having to repair those broken links, or somebody renames a file, renames it to Rev B, but they forgot to make sure that the references were intact. These are all areas where duplicated data can cause some overhead within your organization and within your engineering team. So let's look at an example of this type of cost. I'm going to be using rough numbers and estimations. Every customer has different issues. So some customers have tons of duplicated data. Other customers don't have any duplicated data, but they have other issues with manual entry. And so just because this particular area might not apply doesn't mean that there aren't other areas within your organization where there's inefficiencies. And SOLIDWORKS PDM can be a very valuable tool in eliminating some of those issues. So don't get too hung up on the numbers. The idea here is that we're looking at a template for how to think about what value is being lost by current practices, by the good enough method, and what value could be reaped by just implementing a PDM system that controls files, make sure that there is no duplicate data, that there's one source of truth. So I'm just giving some rough numbers. Your numbers will look different. The amount of time you spend on this will look different. The amount of engineers you have. So don't get too hung up on the numbers. Just use this kind of as a guide for thinking about what value you could be seeing from implementing SOLIDWORKS PDM. So let's take an assumption. 10% of your engineer's time is spent repairing broken references, searching for the correct revision, pack and going data. Say that's 10% of the engineer's time. And you've got 5 engineers in that case, and we'll say a rough industry estimate of $50 an hour for the engineer's time, including overhead costs and benefits and all that kind of stuff. And about 10% of the engineer's time in a 40-hour work week, that's 4 hours a work week, 4 hours per work week, spread across 5 engineers. And let's say that's 48 weeks, add some vacation in there and paid time off. That'd be roughly about $4,800 a year. So it might not seem that big of a deal to spend 10 minutes here or there repairing broken references, but you compound that times the number of times you have to do that per day, the amount of time that that's taking away from design work, the amount of time that's taking away from other value-added activities, and that can be a significant cost. So once again, don't worry too much about the actual numbers. Think about more in terms of what kind of wasted time and wasted effort and value is being lost just in that duplicated data. Another big one, this is probably one of the biggest ones, is manual data entry. So this ranges from either creating bills of materials or combining bills of materials. You've got a mechanical bill of materials or an electrical bill of materials, and you're combining those two things. You're re-entering bill of materials that already exist in SOLIDWORKS or already exist in a spreadsheet, and you're manually entering that information into an ERP or MRP system or a PLM system like an Arena or Agile or some other system like that. And there's also time, for some cases, uploading PDF drawings or solid models or dumb geometry IGES files. Whatever it is, there's usually some other system where the finalized product goes into. And that process can sometimes be extremely manual, entering that information in manually. Whereas with a SOLIDWORKS PDM system, a lot of this data entry could be eliminated just through workflow triggers that can spit out the bill of materials to the PLM system or the ERP system, or automatically upload a PDF or IGES file or step file or SOLIDWORKS file, whatever it is that you are doing today, uploading those files or re-entering information in, that can be eliminated with SOLIDWORKS PDM and some of the automation tools that are available. So let's say that that's 20% of an engineer's time. I've been to customers even last week that customers said they were spending probably 40 or 50% of their time uploading or typing in information into their PLM system, which is not what the engineers are paid to do. They're paid to do design work and engineering and all sorts of other things, not data entry. And so thinking in my head conservatively, but just think about how much time you spend every day. Is it an hour? Is it a couple hours of just typing in information into PLM system or ERP system? That information exists elsewhere. You could be just having that entire update process automated. Let's take again a scenario of 5 engineers that are doing that. Engineers' time, 8 hours a week is 20%, and that's almost $10,000 a year just in entering numbers in a spreadsheet. So once again, there's some hidden cost to manual data entry, and the longer that you continue to do that, the more time is wasted on doing that manual data entry, and that's part of the leak, losing some of that profitability because the engineers are spending their time manually typing in information. Let's also talk about wrong revisions. So if you've ever run into the scenario where purchasing ordered the wrong part or manufacturing cut the wrong part, and then you spent some time investigating, hey, what went wrong? Why was this part, why did we order 1,000 of these? Why did manufacturing cut this part? That's the old revision. The tolerance is different. They should have had the updated drawing. There's time that you spend investigating, hey, what went wrong? And then you spend time digging up the archive files, figuring out, comparing 2 different drawings, comparing 2 different assemblies, what's different, why was the part cut the way that it was, why was the purchase part ordered. That's time and value, and sometimes even very, very concrete costs. If there's a very concrete cost to the amount of scrap, like whatever your product is that it could have been a product, but it was cut the wrong way, or you purchased the wrong product, so there's inventory that's sitting there that's not usable. That's a scrap part, or those unusable purchased parts. Materials for cutting the part, and these can vary depending on what kind of product you're making. And then there's time for machinist or time for purchasing to order the part, or overhead cost just in creating the part. And then there's time for the engineer, the machinist, maybe a manager to do a root cause analysis. Hey, why did we order this? Why did purchasing buy all of these? Why did the machinist do this? All of that can be maybe a day's worth of work. And that's looking at the information, what happened, creating a report for management to say, hey, why did we lose this? That could be potentially, at a bare minimum, $1,800. I've seen customers that have made $10,000 in scrap parts just because they had the wrong revision. The shop floor was using revision A and they should have been using revision B, and that caused a significant increase in the amount of cost just to put that product to market. It's also lost productivity for the machinist and the engineer who could have been making revenue generating parts, but were spent investigating why the revision was wrong and figuring out how to address that. Searching is another aspect of PDM that's a lot easier. If you're using Windows files, it can be hard. Sometimes you stick your metadata in the part file, and that means you have to, when you onboard somebody, they have to learn the smart numbering scheme rather than just being able to search by a field in a database. Knowing where files are, and that can also come in with duplicated data where you have data spread across 2 or 3 different shared drives, and you're not sure which drive is the one that has the latest version, or whether your version that you have on your local hard drive is newer or older than the version that's on the shared network drive. Searching for historical revisions. Maybe you have an archive system, maybe you don't. Maybe you don't know where the old revision of a file is, and it takes time for you to unpack that and look at it, to compare it, and also finding documentation. What was the reason that we made this change? Why? Sometimes you don't even know why the change was made, and so you have to open up the previous revision, look at it, open up the other revision, look at it, and try and visually compare and figure out what's different, why was this changed. That time that you're spent doing detective work, trying to find why this change was made, that can be eliminated with just proper documentation. And maybe there's other associated documents like engineering change orders. Hey, where's the change order that was used to initiate the change that moved it from Rev A to Rev B? How do I find that information? Let's say that takes 10% of your engineer's time, is just once a day spending maybe 45 minutes to an hour of searching for data, maybe 10 minutes here, 10 minutes there, added up to an hour. 5 engineers doing that every day, trying to find the documentation, find why something was changed. Engineers' time, amount of time per week, and then the amount of time or the amount of money per year that the company is spending on paying engineers to find out why something changed when it could be just automatically documented within a PDM system. So that's another hidden cost that could be eating up some of the profitability of a product and eliminating collaboration as well. So speaking of collaboration, we've got this aspect of communication. I don't know if you've ever had somebody send you an email and say, hey, what's the status of this project? Why? Where are we at? Is this released? Is this ready for production? You've got a manager that wants to check in on a project and send them an updated drawing or manufacturing that has a question about a revision, and they need a measurement of something, or they need to understand the model and how this part relates to the assembly. Any of those clarifying questions, status questions that you get via email, you might have to attach files. You have to go find the files, attach them to an email, send them off to the manufacturing group or the manager, maybe add some markups, sending documents for approval with emails and attachments. All of those things could be automated within PDM so that you just give people access to the vault and they can check on it themselves, and you don't have to have that extra time that you're spending looking at emails, generating emails, and updating the stakeholders on the status of a project, when those can be automatically tracked within the PDM system so that everybody knows what the status of that file is, what the status of that project is. So let's say that takes 10% of an engineer's time, just attaching documents. Maybe it's 15%, maybe it's 5%. Kind of customize it to what, when you go through your day today, as you go through your everyday tasks, take a note. How much time did it take you to generate the email? How many emails are you sending every day? How many engineers are there? What's the typical cost for an engineer with overhead at your company? How much time is that per week? How many weeks are you working out of a year? Figure out that cost. That can help you understand what the cost of just doing business is without a PDM system. These are very, very tangible reasons that PDM exists. There's a lot of value that's added by implementing a SOLIDWORKS PDM system in order to address some of these issues. So how does PDM address these issues? We've got duplicated data, we've got data entry, we've got wrong revisions, searching, inefficient communication. What happens if you implement a PDM system? How do these leaks, how are these leaks addressed? And this is by no means a comprehensive list. These are just 5 that I think are important, but depending on how you're structured, maybe it costs, with the different departments involved in order to execute an engineering change order, maybe it takes $3,000 worth of time and effort. But how does PDM work? So duplicated data, when you implement a PDM system, duplicated data can be solved by having a single vault. You're not having to store files across different locations. Users can work locally with their SOLIDWORKS files and then synchronize those changes with the vault. There's version control so you can see which version you have. Is it the latest version or isn't? Which revision do you have? Control access for manufacturing so they only see the latest revision of a file. Manual data entry, when you already have the bill of materials information stored in either the SOLIDWORKS assembly structure or it's stored in the SOLIDWORKS file itself, or there's an Excel document or whatever it is, being able to automatically generate that information as well as automatically export it to an ERP or PLM system, as well as pushing data such as your PDF drawings or the IGES files or whatever it is that you're delivering to those PLM or ERP systems. If you could automate that process and prevent engineers from doing that manual data entry that they might do every day, that's a huge time saver, it's a huge value add, and it's a huge potential profitability area for the company. You might even be able to launch more products because engineers aren't spending their time entering bombs, they're creating new designs, new products, running tests, higher quality. There's a lot of different areas this can affect, but just eliminating some of that data entry work is huge. Wrong revision. If you have a SOLIDWORKS PDM system, you have revision control. Everyone can see what the latest revision is, what the reasons that it changed, why did it move from Rev A to Rev B, making sure that manufacturing only sees the latest revision of a file or purchasing only sees the latest rev. And engineers see the in-between changes. Having that revision control is really important, especially if you need to go back, if there's some sort of audit process. You've got outside regulators, ISO requirements, FDA regulations, FAA regulations. All of those can be aided with revision control. And then searching. When you have a database that's controlling and storing all of your metadata, you need to search by a vendor. You need to search by, hey, how many projects do I have that are pending? You need to search by the revision of a file. You need to search the file history. You need to find the documentation, the reason why this changed. All of that information is searchable within the SOLIDWORKS PDM database. And then inefficient communication, having to send everything via email when you could just automatically approve documents, send documents for review, have links automatically embedded into the notifications so that users have a link right to that file without having to go through the process of uploading the file or sending screenshots or whatever it is that you're currently doing to communicate a design change or send documents for approval or send documents to suppliers. You want to use the web server to use as a portal for suppliers or vendors or manufacturers to get the latest version of a model, and so you approve a document and it automatically sends an email to that user. They log into the vault and they go and look at it, or you don't have to answer those emails of, hey, what's the status of this project? These are all areas that are immediately addressable with the SOLIDWORKS PDM system. And what that means is that those leaks have been plugged, and the revenue and the profit that should be going through the product design cycle actually ends up creating profit for the product and allows time for new products, time to improve products. All of this is very important for the product design cycle. And so maybe one of these applies, maybe two of them, maybe all of them, but I would encourage you to, as you're going through your day-to-day activities today, to just write down, hey, how much time am I spending looking for, repairing references, looking for files, uploading bill of materials or SOLIDWORKS files or PDFs, or entering data into a PLM system. What has happened at our company? What are some of the significant costs that we've seen where someone manufactured the wrong part? What are those stories within the company? How much time are you spending searching for documentation or trying to compare assemblies or drawings to figure out what changed? How much time are you spending answering emails about the status of projects and other emails where you're uploading information into the email to send to customers, send to suppliers, send to management, other engineers? And think about how that's not just affecting you, but affecting other engineers within the organization, affecting other departments. If you're having to do root cause analysis to figure out why the part was manufactured the way it does, it brings in multidisciplinary groups and task forces, and that's time that could have been spent creating new products. So hopefully with that, I'm able to communicate just how important it is to think through the additional costs of just doing what you normally do on a day-to-day basis and trying to get by with a data management system that's good enough. You're putting product out the door, but is it really the most profitable way to put product out the door? And this SOLIDWORKS PDM system is a very powerful product for being able to control your data, being able to automate your processes, and get you back to designing, which is what engineers are tasked with doing. So I want to thank you for joining today's webinar, and hopefully it was a useful webinar and help put some perspective to the hidden costs of ineffective data management. And if you have any questions about data management or any of the topics that I covered today, feel free to go ahead and ask those in the questions pane, and want to thank you for joining us.